Hey Dan, sorry to interrupt you. You are muted.
Sorry about that.
Thank
Again.
you.
Okay. Good afternoon, everyone. Welcome to the Swine Feed Additive Summit by Wisenetics, an event specially designed for swine nutritionists where we will discuss the latest updates brought to you directly from the world's top leading additive suppliers. Our goal here is to provide you with everything you need to know to stay up to date with the latest research in the field without having to leave your home. We believe and hope this event will prepare you for market challenges. I'm Dr. Dan Columbus, a research scientist in nutrition at the Prairie Swine Center and University of Saskatchewan, and I will be your host this afternoon. On behalf of the Wisenetics team, I would like to thank everyone who joined us today. This will certainly be an afternoon full of knowledge and valuable experiences, and we are very happy to have you with us. I am speaking from Saskatoon, Saskatchewan in Canada, but I'm sure we have people all over the country joining us. So feel free to share where you are right now. You can write that on the chat. We would love to know. I would also like to thank our sponsors who made this event possible. Sunhigh, Essential Ag Solutions, MSP Resistant Starch, and Lukta. Last but not least, a special thanks to our speakers who will bring their best to the event, and I am sure it will add a lot to everyone present. Feel free to also use the YouTube chat if you need help or have any questions. Everything will be answered at the end of each presentation. Without further ado, let's get started. I'd like to introduce our first guest of the day, Dr. Joel DeRushi from Kansas State University, who will discuss the likelihood of various feed additive responses. Dr. DeRushi, welcome. It is a pleasure to have you with us today.
Yeah, thank you for having me be part of this, and really appreciate the opportunity to visit with everybody that's attending and share some information that not only we have developed here at K-State, but others as well. So I have my slides. There we go. All right. So yeah, we'll go right into things. And so the topic that, as you set up, I'm going to talk about the likelihood of various feed additive responses. And this becomes very complex from the standpoint of how trial designs are put in place, how responses are tested, what responses are tested, and it really becomes complex to make sure that we're generating the right information and how we generate that information to make sure that we're adequately evaluating different feed additives. So as we get into this, just maybe a little bit of background on our K-State team for maybe those that aren't familiar. We operate a K-State Applied Swine Nutrition team. There's currently 6 of us on faculty that focus on applied swine nutrition. This team started well before I came to K-State, and been very fortunate to be able to be part of the team and continuing the work that's done here. Certainly the work gets done with our graduate students. We often have 13 to 15 graduate students at one time, have many applied, really good staff members, as well as many research partners in the field. And actually, that's where we do a lot of our feed additive work, along with our K-State facilities. A lot of this gets done in the field to test under those conditions. Really, what I want to get into is just maybe setting up a little bit feed additives. So I think everybody on here recognizes that feed additives are compounds in swine diets, and our goal is to enhance performance and health. And those are not separated at times. Generally, when we have a healthier animal, our performance is going to be improved. And so those certainly come together as we try and look at how we use feed additives. So many feed additives are, again, for improving growth, regulating the gut microbiota, supporting immunity. We want to decrease environmental challenges through enzymes or phytase, and there's ways that we can have a reduced nitrogen and phosphorus excretion, as well as improve nitrogen performance. But really, the bottom point is the main challenge with these non-antibiotic, and I want to be clear today, I'm going to focus on non-antibiotic feed additives. It's really have to be justified, or how do we measure consistent effects, or how do we make them economically justified? And really, that's what this next slide gets into on the economics of those. And it becomes complex from the standpoint of how do we measure a consistent response? What does it take for a supplier, a purchaser of feed additives to have the confidence and trust that that consistency response is there? Oftentimes with feed additives, is it measurable? The reality is many feed additives are predicted to give a 1% to 2% response in certain criteria. It takes a lot of replication in a experimental design to get a 1% or 2% difference in growth and feed conversion. We talk about fecal dry matters. We can talk about a lot of different aspects. So how do we design those trials? And that becomes important because we can combine, if we have a factorial, if we have a titration, we can actually increase our power to hopefully find those different effects if interactions aren't present. Really, the next one is that interactions with other feed additives. This is a classic one where if you include one feed additive, how does it interact, or is it response enhanced, or is it masked because you have another one in? And we see this in data. We recently just got done with an experiment looking at a feed additive in response to high levels in nursery high levels of zinc and copper, and they were not additive. In fact, it was negative. And so as we look at these, how do they interact in the gut of that pig, and then are they complementary? And we have to be careful what else is in the diet, because a feed additive may give a response, but it may not in the presence of other types of terms of diet formulation or what else is in that diet. Ultimately, producers have to justify the cost and the risk of their response, and that ties into the projected return over investment. Often you'll hear producers or nutrition companies or those purchasing, they have to have a certain ROI to justify any feed additive, just like they will if they're changing energy of the diet, evaluating any sort of diet changes. So, and that's different based on the individual producer or nutrition company you talk about. I just want to point out we do have a full, it's an updated fact sheet on feed additives at our ksuswine.org website, and I'll show that again. This is the long version to get there, but if you go to ksuswine.org, that fact sheet is part of our nutrition guide, and it'll cover various aspects of all the things I talked about today. One of the things that we have to recognize is that oftentimes feed species are not interrelated. Sometimes we hear, and for some reason my pig picture on the right isn't showing up on this version. If something works in a broiler does not mean it'll work in a pig in the same way. Similar, and I think we've passed the point. There used to be a lot of feed additives, particularly probiotics, other microbial type products that would work in dairy cattle, work in ruminants. They were tried in swine, and again, we have different digestive systems. So again, I think that we've kind of went beyond that. If they worked in a dairy cow, they're going to work in a pig. I don't believe that many people would believe that without actual good data and testing. But even with broilers, we were certainly run into a lot of cases that they may not be response the same in our monogastric species. I'm going to take a step back, and this was a survey done actually right at 10 years ago. And I think if we did this same survey today of the industry, there was 205 respondents in our swine industry in the US of nutritionists and producers, company owners, and they were asked to rank their knowledge of the following areas based on as it related to feed efficiency. Okay, so a 1 is knowledgeable, 10 needs more education. And if we go down this line, they had a good handle on some of the basics: particle size, amino acids, alternative ingredients. But one of the lowest scoring was their general knowledge relating to feed additives other than antibiotics. And I think this because of all the different classes, all the different strains, all the different complexities that come in, that probably actually makes some sense because of the so many different products. It's just not a couple that we have to evaluate. A follow-up question with that is, what is the largest opportunities to improve feed efficiency? So this is narrowly feed efficiency, with 1 the most important, 10 the least. And interestingly, feed additives scored one of the lowest on importance on the minds of them. But I think this is because they felt they need more knowledge. I think you always have to be careful how we look at these numbers, but I do find it interesting it's scored here. But I think, and that was 10 years ago, before we had some of the advancements and some of the new products, some of the things that we have today versus then. If we were to do this survey now, I would suspect that would move up. But also, if somebody doesn't know much about a topic, you may not have a lot of confidence that it's going to improve. So I think that tells us these knowledge gaps and how we need to kind of help filter that together. So back to efficacy and trust. So I want to talk just briefly on evaluating, and then I'm going to get to some data on a lit review summary that encompasses a lot of different feed additives coming up here in a couple slides. But again, in order to develop trust, so if I have a feed additive and there's a nutrition company, an individual producer, a feed mill looking at it, it's ideal that they're going to want to see multiple experiments to look at its repeatability, as well as potentially validate that under the conditions of their production and environment. Many of our U.S. swine producers, many of them, both nutrition companies as well as independent producers of size, have their own research facilities. They'll want to test that, or they'll test it in the field and do some comparisons. They want to look at repeatability. Not everything's 100%, and I think everybody recognizes that. There's situations where a feed additive may or may not give a response. I think people are open to that. They just want to make sure that if it's in their situation, their diets, their pigs, that it will be a response. So I think sometimes we get to where people get nervous about data that doesn't show a positive response. I would say most people actually value a company more showing a no response and then justifying if there's conditions to lead it to such, because it helps advance knowledge where it needs to be placed. I've already talked about replications in these experiments. Oftentimes we need 1% to 2% responses. We're looking to 20 to 30 replications if it's just independent variables. If we do a titration, if we do some main effects and have an interaction, or don't have an interaction, we can combine main effects, then it helps us get our statistical power. But we really got to be thinking about setting these trials up for success. If I look in our history, and we test feed additives all the time, there's certainly cases we did not have adequate replication in the company. We agreed on the protocol. Today, we certainly look to more replication in these feed additive type trials. And the last part is the publication bias. I'm going to get to that at the end. So I'm going to skip several slides, and we're going to talk about publication bias at the end. The reality is many trials that find no responses that are done both within a nutrition company that often does publish data, or it can happen at universities, at some universities where there's no response. That data never gets published. And so ultimately, you're left with a data pool out in the scientific literature that is biased to having more percentage of a response, because non-responses, and sometimes if you submit those to a journal, they get rejected because they claim it doesn't add to the literature. We would highly disagree. We feel it adds to the literature because it helps us in the future determine why or why not some particular feed additives do or don't give a response. But that's a reality, and I'm going to come back to that later on for all of us to think about a little bit more. So what I want to do next is spend some time. We recently had a publication last year come out. Dr. Johnson Rowe is one of our former PhDs. He did a large comprehensive summary of various feed additives looking at feed efficiency. And again, I want to focus, we're going to talk about that, but then we're going to have other variables I'm going to present. This was a wide ranging review. It's published in Animals, and the DOI number is here. So we can provide that. And if you haven't seen that paper, I do think it does a really good job of one of the more modern reviews on a lot of the feed additives that are out there. Classes. So what classes? We kind of broke them into different areas. One, that some of the feed additives that generally go at health status, and that can be both gut level, respiratory, just different immunity type products. And that'd be the acidifiers, essential oils, direct fed microbials, or DFMs we'll use for abbreviation, the various yeast products, and then added minerals such as copper and zinc. We also have some that are more energy and lipid metabolism focused. And so those are the betaine, chromium, conjugatic linolenic acid, or CLA, and carnitine, as well as those that help with nutrient digestibility. And those would be our enzymes based, so the carbohydrases, proteases, phytase, as well as enzyme blends, because a lot of research and a lot of products out there are a combination of those. So those are the breakdowns that I'm going to present on the next few slides for the different responses. So I want to take just a second to set this up. There's a lot going on, but we'll break it down and be pretty simplistic. So what we have along the horizontal axis is all of the feed additive classes I just talked about, acidifiers, essential oils, all the way down to the enzymes, okay? Then we have the number. So this would be the number of treatments that were included in the review compared to a control diet that did not contain them to show a potential response. So for acidifiers, there was 68 individual treatments, part of various trials. Direct-fed microbial 71, you'll get to coppers as 155, chromium 139. So this would also entail different levels, okay? So again, in these trials, there's different levels of probiotics, different kinds of probiotics, all of these things in our direct-fed microbials. And what we try to do then is group them together. And that is, there's some danger in that because we have all the different strains. So we also have to be careful on these reviews because we're really throwing a lot of things together. But what our goal is to try within a class, potentially look at likelihoods of responses. What we have on the bottom is we go from dark blue is a significant positive response in that trial. Then we go and you'll see there's only a few of them in this particular bar, but there's an intermediate blue. So you'll see here like an L-carnitine. There's an intermediate blue above the dark blue. What those represent is a tendency of a statistical response. We also then have the light blue. And in this case, you'll see that light blue is fairly large in number or in scope in terms of the percentage of all the trials. And that is a non-significant positive response. So in the scientific world, we recognize, we stay to our stats, P less than 0.05, generally a tendency is 0.10 and less. What we did in this one was take anything that still had numerical responses. Because if you think about the discussions on replication, the vast majority of all feed additive studies, quite honestly, don't have adequate replication to find differences. So what we did in this one was actually took the numerical and wanted just to classify it. Then we go down the other side. So the light pink would be a non-significant negative value, or the white first would be absolutely neutral, then the pink would be the slight negative, and then we get to the tendency of negative, and the dark red would be significantly worse. And this first one's average daily gain. And what I really want to point out, again, if we want to look at positive responses, regardless of statistics, which again, we stay to statistics, but we want to point that out. For average daily gain, if we follow that blue line and everything down, we generally are in the 50 to 75% of the trials had some level of positive response. Now it varies depending on the trial. And again, this would all be in finishing pigs. All right. So I want to make sure we're staying focused there. It's on finishing pigs. This is for average daily gain. Now, if we look for feed conversion, again, more of the dark blue. All right. The dark blue on the bottom would be significant responses. Again, if we follow the blues up that are still at some level, we're still in that 50 to 75% for most. I would say here we also have a few more that actually have a tendency for a negative response, okay? And again, in most cases for feed additives, we would not expect negatives in feed conversion, right? A lot of them are going actually targeting improvements. We did have cases, and there were certainly cases for some different feed additives where we had negative, but again, trying to point out the likelihood, and back to statistical responses, we saw more with acidifiers, essential oils, direct-fed microbials, some yeast, copper, the CLA products, some of the enzyme products found more in terms of statistical positive responses. And again, if you look at the number of studies, a large number, still in the 65 for acidifiers, copper 149. Again, quite a few to build that database. So for back fat, we also, because we did this on the finishing side, and again, for most feed additives, we would not necessarily think we're going to alter carcass characteristics in cases. And generally, that's what we see across. Again, the blue lines are certainly down, where we see in very few statistical improvements. but we would in cases where we have L-carnitine. L-carnitine would be assumed to have an improvements based on its mode of action. And so that actually came out there. And again, but again, what we also see is more of the pink, which would be a negative numerical, but not again statistical. And again, more of the dark reds in that case. And so again, we have to dig in. We don't have time today in the short period of time to get into all the modes of action. But again, it helps us in certain classes. And again, like for CLA, again, a negative would be, a positive in terms of having less. Let me take that back. So again, while we're having some responses, had more that were actually negative going the wrong way with that particular case. And again, percent lean, kind of the same story. I don't want to spend a lot of time, but again, in that summary, it actually breaks every one of these classes out. It individually gives you the actual numbers. These are just some of the summaries just based on time we have today. So some conclusions for this in feed additives and the likelihood of responses. Again, for average daily gain, there's a group of them that showed a relatively large and positive effects across the reasonable amount of research articles. Again, there was that generally some of that same group helped improve feed efficiency. We talked about some of the carcass characteristics, but also in this one, we point out publication bias. And I've already talked about that some. And the last couple slides I have are going to focus on this. And so I really challenge all of us, both on the academics and the supplier side as well, to make sure that we don't create publication bias so we have the best information when we utilize all the different products that you may sell or that are out there. And this was a summary done back in 2006. Tung and Dr. Pettigrew, when he was at the University of Minnesota, or at Illinois at the time, excuse me, he was formerly at Minnesota, and basically did a review narrow to acidifiers, okay? And basically found some pretty large responses when you did a summary of the literature based on that time point. But this is direct language from that meta-analysis. And I'm not going to read it all, but I will say they basically say the regrettable tendency of some scientists and journals is to decline published results that fail to show significant difference. And this results in an unquantifiable bias in the literature, usually overestimating the value of these technologies, okay? And so again, this problem occurs in any review of published literature, the same way I just presented all the data on. And I think, again, if I have a message, one of the message I want to leave, back to the likelihood to build trust in a product, to build how they get used, presenting producers, presenting nutrition companies, all the information, so we help sort through when's the best likelihood of that because there's a lot of cases that we don't get a response and we can explain why, okay? We just need to keep building that knowledge and not just bury data. So with that, that's what I had for my 25 minutes to visit with you here today. Again, we have a lot of information on these topics at our website at ksuswine.org. And at this time, I can sure entertain any questions that may have come in if we have time to do that.
Yeah, thank you, Dr. DeRushi, for that informative presentation. If anybody has any questions, I'll remind them they can put them in the chat. I'll start with one. At the beginning, you were talking about the knowledge that people tend to have when it comes to feed additives, and I'm just wondering if that low score might be related to the expected effect of 1.2% for most feed additives, and that it's not as obvious with them what the potential benefits would be.
Yeah, I do think that is part of it in the minds of some, because they're looking to try and find any practice that helps improve 3 to 5%, right? We need to have measurable on closeouts, and ultimately I think back to the emphasis on it, some just hadn't spent as much time. Of course, then we were coming out of days where we still had ractopamine in the U.S. We had some tools that significantly improved gain. Today, we don't have ractopamine use. And, and as we look at potential loss, as some have lost zinc oxide pharmacological levels around the world, in the U.S., we have not went down that path yet, but it probably will come here. Again, how do we get incrementally back? We've never been able to replace Paline, but incrementally, there's feed additives that have that opportunity. And so I think back to your comment of a small response. Some may not have invested as much time, but I would say that ship has changed where a feed additive emphasis, especially going into this summer market, there's been a lot of discussion on which feed additives should we be using to improve growth and get carcass weight when this summer market prices are very favorable.
Yeah, you probably start to see more impact when we remove antibiotics and start looking at the overall effects. We have one question from the audience. So when deciding on the best feed additives for swine, what do you consider the most crucial aspect in this decision-making process?
Yeah, so yeah, and I'm the world's word for saying it depends, but it's really going to come down to that individual producer. What is their specific goal? If they're having enteric challenges in the nursery beyond what they can do with their normal program, what feed additives are they going to look at specifically to help with that certain situation? If they have a very healthy herd and they just simply need to try and maximize growth and feed conversion to save on feed cost and to get as much market weight, selling weight as possible, then they're going to narrow in on those. And I think what we've done a better job in the industry is not saying one feed additive fits all situations. I think companies have done a very good job of being more targeted to where specifically it's going to have its best advantage or return on investment for a producer. And so to your questions is really, really important one. But I think it's back to what is the specific goal, because there isn't necessarily one fits all everything. If you have the goal, then you focus in on those and then do your evaluation of what potentially can help. And I think that's the most critical aspect to try and get to the decision process.
Yeah, people want that one answer, but it's always going to be, it depends.
Right.
Okay. I don't see any further questions, so we'll thank you again for joining us and for your presentation.
You bet. Thanks for having me on.
So before we take a break, we will have our next guest, Dr. Emma Song from Sunhai. Today, she will talk about SunGo, glucose oxidase, a functional feed additive used as an alternative to replace antibiotics for animals. Dr. Song, welcome.
Hello everyone, I'm Emma Song, the Global Technical Director of Wuhan Shanghai Biology Company. Today, I really appreciate the opportunity that to introduce a newly developed functional feed enzyme, glucose oxidase, which has a strong antibacterial effect and it is very environment friendly, no pollution, no drug resistance, and no residue. Therefore, it is regarded as a promising alternative to replace antibiotics for animals. The new strain was developed by the Chinese National Academician Yao Bin with plenty of trials and hard work for many years. Finally, they successfully developed glucose oxidase that can be industrially produced and commercial used. I need emphasize that the National Academician Yao Bin is the chief scientist of our group, and Shanghai is only authorized to produce and sell this patent strain. Actually, glucose oxidase was found around 100 years. The functions has been confirmed by many publications, and it has been applied in many fields, such as food industry, medical industry, cosmetics, and now it is expected to be widely used in agriculture, owing to the cost effectiveness of the new development. And like the EU market, almost all countries have allowed glucose oxidase to be applied in feed and animal industry. And for this presentation, I want to highlight the benefits of Shanghai glucose oxidase. This is the reason that we recommend to use it. Shanghai glucose oxidase, named as SunGo, which can significantly improve the growth performance of farm animals, and it can replace with antibiotic growth promoter in the feed because of the major beneficial regulations. It can increase abundance of the beneficial bacteria and decrease the quantities of pathogenic bacteria, which serves as an important regulator to improve gut health. And it can induce digestive enzymes secretion and increase the nutrient digestibility accordingly. How glucose oxidase works. Glucose oxidase specially catalyzes beta D glucose and to produce gluconic acid and consumes oxygen at the same time. So there are two effects of this reaction. Firstly, consuming oxygen to create an anaerobic environment. Secondly, produce gluconic acid to lowering the pH. In fact, this is the action mode for its antibacterial effect. I will explain it in the following. Firstly, consuming oxygen to create an anaerobic environment. Because of the most of cans of harmful bacteria are aerobic or heterotrophic aerobic strains, while the beneficial bacteria are anaerobic or heterotrophic anaerobic strains. Therefore, when consuming the oxygen, it will inhibit the harmful bacteria but boost the beneficial bacterial proliferation. And glucose oxidase catalyzes glucose to produce gluconic acid, which a kind of acid source. The pH of glucose solution would be decreased from 5.6 to 3 point with presence of glucose oxidase. And the lowering pH also inhibits the harmful bacteria. It will interfere bacterial growth by continuously consuming ATP for transmembrane transportation of hydrogen ions from the acid source. The optimal pH for the mostly harmful bacteria is from the neutral to alkaline, but for the beneficial bacteria, it's acid. So when lowering the pH, the environment will be preferable for the beneficial bacteria, but unpreferable for the harmful bacteria. So from this way, it can inhibit the harmful bacteria. Moreover, lowering pH also benefits for inducing digestive enzyme secretion. We can see that the pancreatic juice that will be increased when the pH from 7 decreased to 2. That glucose oxidase could lower the pH, which also benefits for the feed digestion. And thus, the functions of glucose oxidase could be concluded as below. On the one hand, it can consuming oxygen for scavenging excessive free radicals and maintaining the integrity of intestine and reducing pathogenic infection, as well as in maintaining the ecological balance of intestinal flora. On the other hand, lowering the pH and create an acidic environment for inhibiting bacteria, improving digestive enzymes activity, and improve feed digestibility. Moreover, some studies found that glucose oxidase also works on mycotoxin, which can relieve poisoning effect of mycotoxin and protect intestinal health. For these functions, glucose oxidase could be used as functional feed additives, not only to replace antibiotics, but also to improve feed utilization. This study compared the effect on digestive capacity between antibiotics and glucose oxidase. The digestive enzymes such as the lipase, chymotrypsin, and amylase in glucose oxidase groups, the last three, was significantly higher than the control groups and even higher than the antibiotic groups. And the digestibility of the coat protein, calcium, and the yeast extract was also higher than the control groups and even higher than the antibiotic growth promoter groups. And with the higher conclusion of glucose oxidase, the digestibility of nutrients was improved more. And because glucose oxidase works on the intestine, glucose oxidase also can significantly improve the gut morphology. There are 4 groups. The first one is the control groups, and this one is the glucose oxidase groups, and this one is the animals under the challenge test. The last one is the challenge test, but supplement with glucose oxidase. So from the figures, we can see with the glucose oxidase that the gut morphology was improved, not only for the integrity, but also for the villus status. Also, it also under the challenge, the performance was also significantly improved. And following the sequence was analyzed on the fecal microbiome by using the 16-6 XRA sequencing. Firstly, a significantly decreased OTU was found in the antibiotic groups because it's reflecting that a decreased gut bacterial diversity was observed in the antibiotic groups. But with supplement with the glucose oxidase, we can see that the diversity was significantly improved, that it was much better than the antibiotic groups and better than the control groups. And next, the sequence was analyzed on the phylum, class, order, family, genus, and species level, and further identified that the antibiotic groups was promote the anaerobic probiotics was promoted by glucose oxidase, which closely related to the intestinal integrity and the intestinal absorptive capacity, and also related to the better growth performance. More importantly, glucose oxidase is a kind of enzyme product. It is no drug resistance, no pollution, and no residue. It is a green growth promoter, and thus it is promising to be widely used for farm. But there are many key problems that limit the industrialization of glucose oxidase. Firstly, the wild strain has poor thermostability, but as we know that the temperature of feed pelleting is around 75 to 95 centigrade degree. If the enzyme cannot tolerate to the high temperature, it will be lose activity and have no value. Secondly, the wild strain has low yield, but as we know that the utilization for the feed industry, it determines that it should be cost effective. It means that it should have the super high expression level of enzyme protein. Thirdly, the wild strain has narrow pH adaptability, but as we know that the pH in different parts of animal intestine changes a lot, and it is varies for different animal species. If it cannot withstand extremely low pH of stomach, it will be also utilized. In a word, only enzymes with excellent performance and low cost could be widely used. The product stream of our glucose oxidase is co-developed by Shanghai R&D Center and the teams of National Academician Yaobin, using the biological information analysis for many years to construct and upgraded strains, which greatly increase the yield of glucose oxidase and this mutant with good heat resistance, wide pH adaptability, and high resistance to gastric acid and endogenous digestive enzymes. The upgraded glucose oxidase Sango had wide pH adaptability, which guarantees it's tolerant to pelleting process and also efficient in animals' gut at room temperature. And the upgraded glucose oxidase Sango had wide pH adaptability, which guarantees it is efficient in different parts of intestine and suitable for the different kinds of animal species. More importantly, the upgraded glucose oxidase Sango had very good thermostability. The super Sango can withstand high temperature around 95 degrees, and the retention rate is around 80% at 85 centigrade degree, which means that it could be used in mostly pet feed. And Sango is tolerant to digestive enzymes. The retention rate could be more than 90% after pepsin and trypsin treatments, which means that it could hardly destroyed by endogenous digestive enzymes and maintains its efficiency in the animal's gut. And next, we evaluated the antibacterial effect of Sango in our lab. We found that Sango can inhibit the harmful bacteria as the Bacillus, Salmonella, and other strains. It has a strong inhibition effect. And next, we use the different levels of glucose oxidase to treat on the Clostridium perfringens. The result shows that with the higher dosage, with the higher concentration of glucose oxidase, the inhibition zone will be larger. So it means that the higher concentration of glucose oxidase has a better bacterial inhibition effect. And then we compared with two antibiotics. A is the clindamycin, and the second one and the enrofloxacin, and this is one is the glucose oxidase products. And from the result, we can see that glucose oxidase also has the bacterial effect capacity that compared to the antibiotics. And based on the inhibition zone analysis, it can be speculated that 1 unit vial of glucose oxidase, it can be equivalent to 0.4 micrograms per microliter clindamycin. And the antibacterial effect of Sango will also confirm at the different pH. And next is the inhibition effect on the mold. With the glucose oxidase supplementation, the plate get cleaner. Here is the positive control. Here is a negative control. With the higher concentration of glucose oxidase, we can see the mold proliferation could be significantly inhibited. And it is the same for the different strains of the mold. And the flask culture was also showed the same trend, showed the strong inhibition capacity of Sango. Here is a negative control. Here is a positive control. With the higher concentration of glucose oxidase, that the solution become cleaner and cleaner, and as well as the negative control. And next, we evaluate the effect of the glucose oxidase by animal trials. Here, I just share some of the piglet results. The first experiment will conduct on the piglets. There are 7 treatments, the antibiotics groups and antibiotics with different levels of glucose oxidase, a combination groups. And next, that the glucose oxidase supplemented at the different levels, but they without the antibiotics combination. So here is the result compared to the antibiotic groups that combine with glucose oxidase. It held higher average dietary feed intake than the control groups and have a higher average dietary gain. And with the higher concentration of glucose oxidase combination, the performance will be get better. But the best performance was observed in the glucose oxidase supplementation alone groups. And these two groups has the best performance, but there are no difference between the two groups. So from the results that 100 grams of the sango is suitable for this piglets. And the next trial, they have the 6 treatments that is a basal diet without any feed additives and the positive control with antibiotics inside. And 2 combined groups, antibiotic combined with the different levels of sango. And the next one that's based on the control diet that it reduced around 100 calories, but supplement with plant enzymes and sango together. So from the result, we can see that the negative control and the antibiotic groups, there are no significant effect, no matter for the average dietary feed intake, average dietary gain, and FCR, there was no significant difference. But when supplement antibiotic and sango, it improved a lot. And with more glucose oxidase inside, that the average dietary gain and average dietary feed intake with significantly improved. But the best performance was observed on the last one groups, although it has already reduced 100 calories. With plant enzymes and glucose oxidase at 250 grams, it has the highest average dietary gain and has the highest average dietary feed intake, and also have the lowest FCR, showing the best effect. Although in this group, it has already reduced 100 grams calories inside. And from the above lab analysis and animal trials, we highly recommend to use our Shanghai glucose oxidase sango. That it can be used by the different purpose, 100 to 200 grams for improving the egg production and egg quality, 200 to 300 grams for improving the growth performance of animals, and 300 or more for treating the diarrhea of piglets and glandular gastritis for poultry. And we can provide the different types. The pellet types or the water-soluble powder type, it can be used in the feed, and also it can be used in the drinking water. And actually, the animal husbandry environment is very different and complex. It is not stable to completely replace antibiotics with a single product. Thus, based on our experience and the former EU experience, lots of animal trials analysis, we highly recommend to use a combined product to completely replace antibiotics. The glucose oxidase is the core of our combination products, with assistance of the organic acids, planting enzymes, probiotics, and functional additives, sodium butyrate. The component has diverse functions. Glucose oxidase consumes oxygen and lowering the pH for inhibiting bacteria. Organic acids exert antimicrobial actions through pH depression, and enzymes improve digestibility, thereby indirectly overloading microbial balance. Probiotics improve health and growth by altering the intestinal microflora balance. Sodium butyrate improve immune system and enhance the resistance to disease. The thinner effect of these components can not only replace antibiotics, but also related intestinal microflora, maintain gut health, and finally improve growth and production performance. So this is a brief introduction of glucose oxidase. Thanks for your time.
Okay, thank you, Dr. Song, for that presentation. I'll start with a question for myself. So one of the things that you showed was that the glucose oxidase a lot of times has a better impact than antibiotics. And even in the one, it looked like when you combined it with antibiotics versus on its own, it worked better. I'm just wondering what you think is the reason for that, because that's not something we normally see with feed additives.
Yes, that glucose oxidase. We have already did a lot of trials that we use the glucose oxidase alone or combined with the antibiotics. And at first, we see that there was a synergistic effect of the antibiotics and the glucose oxidase, but for the high quality management in the farm, we see that the glucose oxidase alone supplement also can achieve the best performance without the antibiotics. So I think that the mechanisms between the glucose oxidase and the antibiotics is different, because that the antibiotics improve the growth performance because it reduces the load of the microbiomes.
Mm-hmm.
But for the glucose oxidase, it can improve the diversity of the microbiomes and enhance the abundance of the microbiomes. In the long term of the rearing, if we have the very good management and high quality of the feed, that it will be achieve the best performance for the long term rearing. So that we recommend to use it that without the antibiotics, and can totally replace antibiotics if that the good and have the very high the quality that the feed like this.
Okay, thank you. From the audience, we have a question. At what age or stage of production should pigs start getting glucose oxidase for the best results?
That from our the experience, that we suggest to use the glucose oxidase from the weaning stage. That because that it can significantly improve the elevate the dairy rate of the weaning pig, and it can improve the gut development of the piglets. And then, as we know that the better gut health and the better intestinal morphology and development, it can further improve the feed intake and average dietary gain in the late period. So for this question, that the age is from the weaning stage.
Okay, thank you. Seeing no further questions, I'll thank you again for your time and your presentation and joining us today.
Thanks, Dan.
So now we will have a 10-minute break. Please take the opportunity to stretch your legs, go to the bathroom, have some water, or grab a cup of coffee. We will be back soon. Before we go, however, I would like to thank our sponsors again, Sunhai, Essential Egg Solutions, MSP Resistant Starch, and Lukta. We'll see you in a few minutes.
But I'm just getting started. intoxicated. I don't know why I get frustrated. Oh, babe, love was on your mind. Last night we flirt by your side. Oh, you can't deny. I bet you wish it's you and I can see that you still try. Oh, your sweetest dream. Time flies by and you still look so dumb. Getting bored too soon of your new hun. Don't even get me started on. You think you're a beat to every girl's drum. I see a boy who missed his home run. Boo-hoo, you can miss me with that shit. I think of you when I'm intoxicated. I don't know why I get frustrated. Oh, babe, love was on your mind. Last night we flirt by your side. Oh, you can't deny. I bet you wish it's you and I can see that you still try. Oh, your sweetest dream. But only in your memory. Only in your memory. By your side it's you and me. Only in your memory. You wish it's only you and me. I really need to get some sleep. Used to say it's you and me. Only in your memory. Only in your memory. Oh, babe, love was on your mind. Last night we flirt by your side. Oh, you can't deny. I bet you wish it's you and I can see that you still try. Oh, your sweetest dream. But only in your memory.
Baby, I'm calling for you, and I'm stuck in a loop. Baby, I'm calling for you, and I'm stuck in a loop. Baby, I'm calling for you, and I'm stuck. Baby, I'm calling for you, and I'm stuck in a loop. Baby, I'm calling for you, and I'm stuck in a loop. I'm stuck in a loop. Baby, I'm calling for you, and I'm stuck in a loop. Baby,
Baby, I'm calling for you.
And I'm looking for you.
Baby, I'm calling for you, and I'm stuck in the loop. Baby, I'm calling for you, and I'm stuck in the loop. Baby, I'm calling for you, and I'm stuck in the loop.
Hello again, and welcome back, everyone. I'm Dr. Dan Columbus, and I am your host this afternoon. I hope you enjoyed the break and took the chance to recharge your batteries, because here we go again. Let's continue with our presentations and go on to our next speaker. Please remember that at the end of each presentation, we will have a Q&A session. So I'd like to welcome Dr. Ashley Wagner from Essential Ag Solutions to talk about the impact of monoterpenes on the brain-gut axis. Welcome, Dr. Wagner.
Thanks for having me. So let me get this started. So I just want to start by saying that this is a partnership. I actually am the director of U.S. Business and Technical Sales for Probiotech, and we manufacture the product CCC for Essential Ag, which is why I'm here today with everyone. Yes, I am going to talk about the brain-gut axis, and that's not a mistake. And we're going to get there. But first, I do have to talk about the gut-brain axis. So this is not a new topic. It was actually suggested in 1993 by Light and colleagues to refer to the study of the gut-brain axis as the study of microbial endocrinology. However, this field focuses on altering the gut microbiota by increasing the number of bacteria that can produce mammalian neurotransmitters and their precursors. And these are things like dopamine, norepinephrine, serotonin, GABA, and many others. Additionally, this field examines the mechanisms that the gut microbiota influence the nervous system, such as impacting the HPA axis, stimulating the vagal nerve, secreting short-chain fatty acids that could activate microglial cells, and impacting the blood-brain barrier permeability. So this field, the researchers that are working in it, are actively trying to further elucidate the mechanisms between enhancing these neurotransmitters and then their systemic impacts. Because we do know that stress has systemic impacts. And they are actually a variety of things, like impairing protein accretion and skeletal muscle growth, impairing digestion, nutrient absorption, and metabolism, reducing fertility, impacting milk production and the quality of that milk, increasing the susceptibility of the animal to infection and diseases, and increasing low-grade inflammation. But this impacts production. This impacts your bottom line. And if we think about these physiological impacts and how they would impact production, well, think about the nursery, grow, finish. If we're reducing muscle growth, that's a problem. If you are dealing with sows and you are reducing fertility, that's also a problem that costs money. Additionally, milk quality. If we are not producing good milk or enough milk, we're not going to have a heavier weaned piglet. And so again, that costs our bottom line. But I've started talking about stress without actually defining it. And, I think about myself when I talk about stress rather than animals. But there are a number of definitions for stress that actually apply very well to livestock production. So stress is defined as the effect of all external and internal factors that can negatively affect the performance of an individual and alter the psychological and physiological and or physical health of that organism. And another definition of stress that I've included here is a state of mental or emotional strain or tension resulting from adverse or very demanding circumstances. And, think we can all agree that how we raise animals is demanding on that animal, whether that's from group housing or transportation, the stocking density, transitions to feed, handling, and environmental stress like heat stress. So our animals, even with good management practices, are impacted by stress. So I mentioned I'm not going to talk about the gut-brain axis. I actually want to talk about the reverse of that, the brain-gut axis. And we're going to get there, but I'm going to talk about altering it. And I'm going to talk about that through monoterpenes. We need to first have some definitions. So essential oils are not a new topic in livestock nutrition and, in our industry. They've actually been focused in research for a number of years, but this has been more looking at altering the gut microflora. And there's a lot of confusion about essential oils when we start talking about them. And I don't know if that's because of what's going on with humans and essential oils, or because we're not all using the same terminology. So let's start there. Essential oils are derived from plants, and you can define them based on the botanical species you derive that. For example, lavender. But if we're going to get a little more specific, then we need to look at the part of the plant that we took that essential oil from, whether that be the leaf, a root, seed, fruit, or flower. Any of those can impact what you are actually extracting out. To get a little bit more specific, we need to look at the mode of action. Are you distilling? Are you crushing? And all of these things are going to impact what you get in that essential oil. But to be the most specific when we are discussing these things, we need to talk about the chemotype, or the active component, and that chemical compound. So for example, thyme, that's often used in gut health products, you're actually looking at thymol or carvacrol as your active ingredient, be the chemotypes. But chemotypes have variability, and that could be due to the plant variety that you extracted from. It could be due to how the plant was grown and where it was grown, the soil, the environment, the moisture content, the time that you harvested. All of that can play a role in the level of those chemotypes that you extract. So let's take a look in this example of cinnamon extract. And we're just looking at the bark versus the leaf. I want everybody to focus their attention, and I hope you guys can see my mouse, but on the green. So this is linalool. This is a chemotype, and it is in green. You can see that the bark and the leaf have pretty similar composition. However, if your interest wasn't linalool, and let's say it was this lighter blue, terpenine 4, you can see that the bark has a lot more than the leaf does. Similarly, if you look at the variety, so each individual plant rather, grown in the same region, you're going to have different composition. So I mentioned carvacrol and thymol already. If we look, the dark brown is carvacrol, the gray is thymol. From plant to plant, there is a great degree of variation with these. So if we want to really get technical, we should talk about the chemical structure. And chemotypes are all classified as terpenes. Terpenes are volatile. They are unsaturated 5-carbon cyclic compounds. And they can then be classified further based on ligation. The point is that they're volatile. Everybody knows what oregano smells like. And that's because of the chemotypes that are commonly found in oregano. These compounds are volatile. They have a smell, and they do activate our olfactory receptors and then trigger our brain. So I'm going to be speaking specifically about the C10 ligated form of these terpenes called monoterpenes. And again, I mentioned they are volatile. But the other thing we've already kind of introduced is that there are different therapeutic uses of these compounds. So does it have anti-inflammatory properties, antimicrobial properties, antiviral properties, decongestant properties, or can it have anti-anxiety and antidepressant qualities? Well, as a matter of fact, there are certain monoterpenes that do have anti-anxiety and antidepressant qualities. So that's now where we're going to start talking about the brain. So what was done in a series of research trials was they actually took groups of pigs and they sedated them, because you can't take a PET scan of a pig when it's not sedated. And they had them breathing, so through an olfactory delivery mechanism, either control, so just water, or a blend of monoterpenes. And then they took a series of PET scans. And what they found was actually that this blend of monoterpenes was able to activate areas of the brain involved in the reward system, emotion, memories, happiness. So that was really exciting. But in that studies, there was no stress. So what if there is stress? Well, they repeated the first bit of this, where they looked at, just taking those PET scans and looking at the brain. And yes, they did see again in this same way they saw previously, that the areas of the brain that were activated were those evolved in learning, emotions, and again, that reward and motivational centers. But stress. So they injected them with synthetic cortisol or synactothin. And then they waited 30 minutes and then they took the scans again. And this time what they found was that there were different areas of the brain that were activated with the synthetic cortisol. But when they had the synthetic cortisol plus the monoterpenes, those areas of the brain weren't activated. So the monoterpenes were able to mitigate the brain activation caused by that acute stress. So is it just that easy? Can we now just change all of these things? Well, we have to prove it. So let's talk about this crosstalk between the brain and the gut. And again, I'm going from top down, not bottom up. So let's look at what's going on in the brain during stress. And this is super complicated, so I'm going to try and break it down. Let's look at norepinephrine and epinephrine as our adrenaline. These are going to work together during fight or flight. And then you get a release of cortisol as well. So this is our stress hormone. So whether we are a prey animal that is running from a predator out in the wild, oftentimes under stress, and I'm sure you've seen this with livestock and pigs especially, you'll see them defecate when they start to get a little nervous. Well, that's because these norepinephrine and epinephrine are working together to mobilize the body to stop normal homeostasis, especially with the digestive tract, because we're going to get ready and have to run from that predator. On the other side of things, we have serotonin. Serotonin, think happiness. This also is involved in sleep and plays a role in hunger. So very simply, if we had a weighted balance and there were stress, we'd have more norepinephrine, epinephrine, and cortisol, and less serotonin, and would not feel very happy. On the other side, if we are not very stressed, we'd have more serotonin and we'd feel happy. So again, I mentioned I can't get through this without talking about people, because we think about ourselves when we think stress. And people are highly stressed. And, the American Psychiatric Association just released this saying that Americans are very stressed. In fact, of the population that they examined, 27% of adults said they are so stressed they can't function most days. And we know that stress is associated with detrimental diseases in human beings: high blood pressure, heart disease, stroke, immune dysfunction. And stress has been shown in humans to play a role not only physiologically on their ailments like headaches, muscle tension and pain, changes in their sex drive, an upset stomach, but also affect their mood, anxiety, restlessness, a lack of motivation, and then their behavior. Maybe not wanting to go hang out with friends, maybe exercising less often, or over or under eating, or abusing drugs and alcohol. But luckily for people, they can take drugs. So there are a number of drugs out on the market to deal with these types of things in people. And two of the main classes are SSRIs. And so these actually cause more serotonin to be available. Check, happiness. The other one are SNRIs. So more serotonin and less norepinephrine. Okay, that's our weighted balance. I've got that. That makes perfect sense. Unfortunately, we can't do this with livestock. So how do these monoterpenes work? Well, they work in the same manner. So they actually increase brain serotonin levels. and have been associated with the regulation of stress and their feeding behaviors. So let's talk about some of the things that have been shown with these types of monoterpenes in pigs with a stressor like mixing. Well, mixing, we normally see aggression. And in this trial where they offered the monoterpene blend for 3 days prior to mixing, they saw a reduction in the total duration and the average duration of those aggressions. Additionally, they looked at a change in cortisol from a 4 to a 24-hour post-mixing period. And they saw that with the monoterpenes, cortisol reduced, but did not with the control group. And the number of pigs per pen that had severe to moderate lesions following the mixing, 3 days specifically, was statistically reduced. So is it just this simple? Can we just alter the brain and then get systemic benefits? And that's something that these monoterpenes have the potential to do. And I didn't mention when we were talking about people, but I will just very briefly. If not all people take SSRIs, SNRIs to trick their brain. Some people can go for a run and it makes them feel better when they're on what my daughter's therapist calls worry road. The other trick my daughter's therapist actually has taught her is to bite a pen and hold it because it causes her to smile. And after 30 seconds of doing this, she's off worry road because her brain is releasing serotonin and tricking her into being happy. Just like these monoterpenes can trick the animal during a stressful period into not physiologically responding to the stressor. So that's what we set out to do. Actually, was to really validate this concept from the brain to the gut. And so we wanted to see, can we do this? There'd been several trials looking at the performance of animals with these monoterpenes, but what about actually altering that gut? So I'm going to introduce tight junction proteins. I'm sure that many of you are aware of them, but just to make sure we are all on the same page, what are they? These are actually scaffolding proteins that help hold together the intestinal cells. And they do this so that way that no pathogens or toxins can pass through that interstitial space. And you can see that very clearly in these pictures, how they're making a nice roadblock. I like to think of it as, maybe buildings on a city block, and the interstitial space is the alleyway. And our tight junction proteins are roadblocks. And so E. coli, who we do not want to come all the way across, it could be driving down the street, but that roadblock's going to keep it from going inside. However, if we have a problem with our tight junction proteins, which this has been very well demonstrated that during times of stress, like weaning, fasting, heat stress, great examples, we do see that these tight junction proteins are compromised. And then this results in leaky gut. So let's go back to our car, our E. coli car, and let's say that roadblock, it's not really that strong. It's not taking up the entire alley anymore. Now it's kind of crumbled. And for that bad guy, he can drive right on by. Might scratch up his car, but he's going to do it. Well, in that case, we now have an infection. And that is what we don't want. So that is why a leaky gut is a problem. And so we wanted to look specifically at these tight junction proteins. So to introduce the product, CCC is a formulated blend of monoterpenes with anxiolytic capabilities. So they are looking to be anti-anxiety, antidepressant, and again, to help the livestock cope with the stressors that they're living under just a bit better. So that way they physiologically respond better. So again, due to various stressors that we have. So for our trial, we used a commercial research farm is where the pigs were being held. So they left the sow farm, got on a truck. So weaning, stress, check. They were then transported for 1 hour and fasted during that transportation. Check. That's another stressor. And then they were taken to the nursery farm. So they were separated into 24 pens per treatment. The treatments were either the control or the CCC. And then we followed them for 7 days, and we euthanized 9 pigs per treatment. So what we looked at several of our tight junction proteins. We saw a numerical increase in every one of them. And again, we would have liked to have seen a higher number of animals, but this is a preliminary trial. With our low number of animals, we did get close to a tendency. So it is very hopeful that if we do this again, we will see that. What I like about this is we see it with every single one. There is an increase in every single one of our tight junction proteins we examined. And not only did we see this, but we also saw a tendency for an increase in body weight at the end of day 7. So both items taken together, it appears that we had a protective effect. So possibly, yes, more research is warranted for this, but I do believe that we are showing that we're able to impact from the brain to the gut. So thinking about your stressors, where are other places? And we do have some performance research. If you have any questions on CCC and would like to know more about it, maybe how to use it or how it's working, please reach out to an Essential Ag representative. I'm sure that they would help you. And with that, I'm all done. I think I can just hit stop sharing.
Okay.
I think that's it.
Thank
Okay.
you, Dr. Wagner, for that. Very engaging. I think I might go look up this product because I spend a lot of time on Worry Road. So I'll just remind everybody that if you do have questions, to put them in the comment section, and we will make sure to address those. I'll start with a question like with the other ones. The first study you kind of mentioned was specifically inhaling the product or the monoterpenes, right? And you had that effect. But I'm assuming you're feeding this in the diet. So is the effect
Yes.
right? So is it just that it has to be absorbed and it doesn't matter the route, or what?
Well, so that's a great question. So, what we've seen with the research is that it, number one, has to be smelled. It has to be smelled. But you think about smell and you think about eating. Well, if you are consuming something, especially something that is volatile, you smell it. You smell it before you put it into your mouth. And because smell and taste are linked, obviously consuming. But so we do see an effect with just the smell on the brain. For our performance work with this product, we've looked at both using it in the water as well as in the feed. And I will say that if you have it in the feed, the entire barn smells. It has an earthy, citrusy kind of smell to it. So it's a very, very different product. And again, the whole kind of thing, brain gut, is different.
Yeah. So smell is obviously important then. Are there like specific effects that you would see with ingestion that you might not see with the inhalation?
Yeah. So what we've seen with our research is that we do get an effect on as I mentioned, the brain, but to get full-blown performance benefits, we like to have them consuming it for 3 days at a minimum. 5 days, you get maximum efficacy on your changes in your performance. And so again, if you're just using it for like aggression, you will see a difference after using it for just a few days of them smelling and consuming to have that full body behavioral response.
Yeah. Okay. Question from our audience. Do all monoterpenes have the same effects, or are there variations in their impacts based on their sources, blends, etc.?
Oh, so yeah, no, that's a wonderful question. So yes, absolutely. Every monoterpene has a different effect. And actually carvacrol that I mentioned that has gut health benefits, it's also a monoterpene. So it really does matter what monoterpene you're actually utilizing, and then again, what its job is. So that's why I started the presentation kind of trying to get us all on the same playing field, because people are out in the industry going, oh, essential oils, I'm using oregano. Well, okay, but are you using oregano that has a lot of carvacrol? Or maybe it doesn't have enough. And so then what is the purpose of that? So I like to start when I talk about these things, again, making sure everybody's on the same. So yes, there are variations. And if you don't use, again, you need to go through and look. So if somebody's developing these types of products, you need to go through and look at which ones have these types of benefits. So we start with a single compound, and then we start adding these compounds together to get an additive effect. I hope that answers your question.
Yep. So another question, will CCC be given continually or at intervals when stress is noticed?
Again, another wonderful question. So it really depends on the stressor that you're trying to reduce, right? So if the stressor is, let's say, just being a sound, I will use myself as I'm a mother, I am a parent. Having children is stressful. And so just lactating is physiologically stressful. But then they get taken away, in the case of this house. So you will see the product being used throughout lactation. So it might be an entire period. Other times, if you're dealing with something like weaning stress, you can just pulse it, or entering. So put it just in the starter, or entering the grow finish, barn, just to try and deal with the stress of kind of entry. So it depends. We do have a nice trial going on with heat stress in utero. And so again, heat stress, that's a constant stressor. So in those cases, you'd want to keep it in. So truly it depends on what stress you're trying to alleviate.
Okay, thank you. I'm not seeing any more questions, so we'll thank you again for your presentation and your time.
Okay, thank you.
Oh, sorry, we do have one more. Oh, maybe. Can we bring her back or no?
Yes, Essential
There we
Ag
go, okay.
Solutions. Essential Ag Solutions. That is a where you can access this product. So.
Okay, thank you. Now we'll let you go.
Okay, thanks.
Thank you. Okay, so at last but not least, I would like to welcome Dr. Emily Otto-Tice from LUCTA, who will talk about the art and science of palatability. It's more than a flavor. Welcome, Dr. Otto-Tice.
Oh, thank you for having me. I've enjoyed listening to all the presentations, and her presentation leads right into the concept of palatability and how taste and smell sensory is impacted. So I appreciate being part of the summit today. So I'm going to get right into it. At LUCTA, we are expertise in the palatability realm and understanding how smells and taste can affect feeding behaviors in multiple species. And so that's what I'm going to share with you today. Let's see, hopefully the slide will advance here. There we go. Okay, so my overall content, just to give everybody a heads up of what I'm going to be discussing, is I'm going to give a brief introduction of how palatability concept works, and specifically about sensory feed additives and how they're categorized into volatiles and non-volatiles and how they're perceived by animals, and then work into how we can take that knowledge and apply them in strategies, especially in two categories of production for pigs in the early wean piglet stage in nursery programs, as well as a slightly different aspect and application for sows experiencing heat stress. Let's see, let's go next. So first I want to define what palatability is. And there are several definitions dating back to the early 80s. And it originally was defined as what's pleasing to the palate. When you yourself go out to dinner or you're cooking foods at home, you know what ingredients or different menu items you like for the way they hit your palate and you taste them. But over time and in the years to follow, they've built on that concept of it's not just about how it feels in the mouth. It also is about the taste, the smell, the appearance, temperature of the ingredient or foodstuffs being provided, and the texture or the overall mouthfeel. And then they also include aspects about the experience, like smell is actually one of those senses that stimulates responses in the brain that can actually induce memories and emotion, just like was previously presented on the gut-brain axis information. But the biggest part is that it's actually learned. You can actually have things that you learn to smell and learn to discern different things. So these concepts are intertwined with palatability, not only for taste, but also smell and how the animal responds in a different learning environment, or their experience of their environment and their metabolic state. So going into a little bit more about how the function and stimulation of palatants and sensory feed additives work, what we're really trying to do is stimulate the two systems that modify feeding behavior. The first is the hedonic system, which is the reward center. These are stimulated by chemosensors of chemical compounds. Once the feed is ingested in the mouth, it sends up signals through the central nervous system into the pleasure center of the brain. It's releasing those positive experiences or negative experiences, and it's not all good all the time. Different compounds do different things and for a purpose. But these reward centers can actually create a learned experience that shows that the pig enjoys that feed ingredient, for instance, and it improves acceptability of a new feed or something new and different in the environment. The other system is the homeostatic system that really triggers through the post-ingestive state. These are the signals that stimulate the endocrine feedback functions and the recognition of the actual uptake, absorption, digestibility of the various nutrients. And then it also is stimulating those hormones that control the appetite, whether they're like, okay, I'm empty stomached, I need to eat. So ghrelin shoots up into the system, sending a signal to the brain, hey, look for food, I'm hungry. Or once the animal starts ingesting feedstuffs, the opposite effect of feeling of satiation besides just the physical capacity of a full stomach, but that satiation feeling throughout the GI tract from CCK release. So it's not just about not only the pleasure center response and the hedonic system and reward, but also the homeostatic and the metabolic system that is providing feedback to the animal of stimulating and controlling their voluntary feed intake and feeding behaviors. So what specifically are those sensory additives that we're talking about, and what are those compounds that work? And we classify them basically in 3 categories. In reality, there's 2. The volatiles are those aromatic compounds that you are first introduced to through the sense of smell. The non-volatiles are compounds that may not have an aroma, but they have a chemosensing ability with the taste receptors in your taste buds, which are also found throughout the GI tract. And those compounds are equivalent to like sweeteners. We talk about the flavor of umami, identification, association with protein or savory items. And then one area we call diversity, where it can actually be a combination of sweet and protein, the Maillard reactions, for instance. And a nice representation of this would be when you grill meat on the barbecue or you sear it in a hot pan and you get that nice caramelized crusting, that is a different kind of flavor compound that kind of connects both umami and sweeteners and creates a whole new complex taste that your tongue will pick up. And then the third category is there's compounds that have both. They may have some volatile attributes to them as well as taste attributes in the non-volatile sense. So first I'm going to dive into the odor. Again, smell is usually the first thing you come to when you're cooking food for yourself. But animals, that is also their first experience to something. They're sensing out their environment, trying to get their bearings straight. They're looking for feed ingredients to meet their needs. So odorants or volatiles are those small molecules. They are actively present and easily to evaporate into the air, and they hit the epithelial nasal sector in the nose. This table provides just a few examples of some volatile compounds and where their precursors could be developed from and why they're important in identifying specific ingredients as nutrients. So there's different hexanols that are actually a volatile compound associated or broken down from polyunsaturated fatty acids. We know fatty acids or fats themselves are an energy source. So the animal learns that if they indicate or smell or detect that compound, they can discern that they're coming across an ingredient that's going to provide an energy source. Whereas the further on the table, the metabutanols on the lower end, they are actually associated or precursors from amino acids. So they're indicative of recognition of a protein source. So there's different compounds that could be remnants or subparticles of the precursors as they degrade or as they are in the environment that the animal can detect. And so why is this important? We talk about the olfactory sense and why it is such the first experience in regards to palatability. So we also have learned over the years that animals and species are very different in their perception and discernment with smells. And this chart shows the number count of functional genes relative in the olfactory receptors in the cells in the nasal cavity. Rodents and pigs have a very high number and are some of the animals that have the highest numbers of olfactory sensory ability in their nasal cavities. Whereas cattle and dogs, we think, we use dogs like the U.S. Beagle Brigade in looking for meat products to prevent things coming in across our international borders, or we use them in health aid network where we understand there's some dogs used to detect early signs of cancer in people. So there's different odors that they can detect that are more discernible than what further down the road humans. We think ourselves that we can smell things pretty well, but relative to these other mammalian species, we're pretty low on the totem pole in regards to our ability to really discern specific compounds. So the other side of the palatability equation is our ability to taste and our perception of things that we taste. I'm going to talk a little bit more about these specific attributes. And the non-volatile perception begins in the mouth and the oral receptors. And for a long time, we thought that taste was strictly limited to the tongue and area. And what we have found over the past, 3 decades at least, moving into possibly 4 decades, is these taste receptors are actually located in various types of specific epithelial cells all the way through the digestive tract, from the esophagus down to the large intestine. And what these different taste receptors are doing, they may act similarly like a taste bud. Each taste bud has a multitude of taste receptors within them, and they're not just one specific taste they're finding. Our 5 primary categories can actually be found in every single taste bud receptor, and they're throughout the different areas. It's just that they might have a more intense reaction based on where their location is and what their ability to find. So for instance, in the stomach, they have a high propensity for receptors that are still focused maybe more on recepting proteins and sugars as well as bitters. But as you move down the GI tract, that may shift to more sugars or proteins for absorption, digestion purposes. And then as they go on, the other thing is that they do in signaling the hormone structure, whether it's like I mentioned earlier, if the animal is eating, they've already had the physical fullness in the stomach, but as that feed stuff moves down through the digestive tract, there's more CCK, which will signal satiation and trigger the motility of the stomach, or motility of the muscles to move the digestion along through the GI tract. So it's a very interesting concept that the taste and perception of these different characteristics of sweet, bitter, umami, sour, and salty can be found throughout the GI tract and help do different signaling mechanisms. So Lupta has a long history, and like I said, we have a over 40-year history of expertise in the field of palatability and understanding how different substances or compounds, whether they're volatiles or tastings, can work in different species. And so some of our work that we strive to excel at is in the young animal. And for instance, setting up preference trials, what products or what compounds would we think the animal would prefer over others? So in these 2 graphs, there's 2 distinctively different types of palatants. On the left-hand side, these are milky, cheesy. Maybe you want to think of them as categories that would be reminiscent of maternal fluids, of milks from the sow, colostrum, also thereby giving a little bit of protein note with the cheese aspect and energy with the milk sugars. And on the right-hand side, they tested different varied fruit or sweetness profile products. And I'll explain the differences between the 2. So when these preference trials are run, they only run 2 products at a time. So a control versus a palatant flavor. And that diet is void of any kind of aromatic that would be preferential to the animal. And so it's a side-by-side. They didn't test all 5 at the same time. So anytime the animal had a side-by-side test of an aromatic, if it exceeds 50%, they showed a moderate preference. If it exceeds 70%, it's usually indicative of a strong preference. And so in both categories of the different things, you'll note that most of the flavors in the milky vanilla or the milky vanilla cheesy showed a moderate to a strong preference in young piglets compared to when those individual flavor compounds were tested against a control diet. And you'll also note that the milky citrus wasn't as favorable or preferred. It was actually an aversion with it being less than 30% reference and preference study. So there are different compounds that we think they might enjoy and others that they don't. Same thing on the fruity side with the strawberry and berries. Not all strawberries are created the same in this instance. We had a wild strawberry or fruits of the forest, which was a blend of different berry compounds. They perform well, but the one strawberry, for whatever reason, the compounds utilized to create that flavor and aromatic was actually not perceived well amongst the pigs. So there's a lot of research and science. Just because it's one thing, you really have to understand and understand the specificity of those volatile compounds and tastant compounds that really drive the preference in these animals. In regards to umami taste, which is the newest of the tastants, even though it was discovered in the 80s, we didn't know much about it, but it's the one that drives the sense and perception that there's protein. It's also referred to as the savory taste. And it's unique because there's a lot of research has been conducted that shows that when these receptors in the gut lining, especially in the small intestine and epithelial, appear, that they are actually activating protein synthesis. They're activating the ability for enterocytes to have amino acid transporters put in. The other tastants are there. So they do stimulate and signal cell activity derived to either help improve absorption of amino acids, the presence that protein is there, in driving further digestion. It can even stimulate other enzymes to be released as the animal is ingesting the feedstuffs that contain umami sensing products. The middle graph is an in vitro graph where they were looking at cell culture and epithelial cells, basically to determine, are there certain compounds, or what are the certain compounds that can activate and bind to these tastant receptors in the epithelial lining. So I understand these may be difficult to see, but the no response was a negative control solution provided to these cell cultures, and there was no binding or activation of the tastant receptors in the GI tract. However, when solutions of either monosodium glutamate or a unique umami nucleus compound were added to either of these, they saw a strong response and a color change. They used phosphorescence to indicate a strong binding and activation of these taste receptors. Moving into further development of an in vivo study in looking at preferences, they fed some young pigs diets that either had 1% MSG or 2% MSG. They saw a greater preference with the higher inclusion rate of the MSG. And then they compared it also to the umami compound at a much smaller inclusion rate and saw a significant preference over the other two diets. So that's some of the early research in the umami base. So how would we apply this in a nursery application and what we're looking for? Since the challenge of early wean pigs and stress, they don't want to eat. And what we're trying to do is we want to get piglets to take their first bite of feed within the first hours post-weaning. A lot of times the majority of pigs really don't start eating until 24 to 36 hours after weaning, and we'd like to see that happen sooner. So what can we do as a management technique to enhance that early post-weaning feed intake and curiosity to drive those pigs to the feeder? So this is some work that Luta conducted about 10 or so years ago and was presented at the Digestive Physiology of the Pig conference when it was held in 2012. So they looked at early weaning, they looked at the early first week post-weaning diets, feeding 3 different diets. There was a control phase 1, that same diet with just the volatile aromatic compound, which was considered a maternal, or the familiarity, building off of that imprinting aspect of the piglet. And then a combination of maternal flavor and umami compounds with the aromatic all in one. And what they did find and see was that there was increase in feed intake for both sensory feed additives on top of the control diet, but there was definitely a significant increase in feed intake over that first 7 days compared to control when it was the compounded aromatic plus the umami. And that also, because of the increase in feed intake, there was an improvement in average daily gain. The other side, a little bit more recent, we helped fund a study at Purdue University that was recently presented at the Midwest Animal Science meetings last month. Although this data, again, was not statistically different, the researchers and PI, Dr. Rickert and his graduate student, really wanted to hone in because they did notice that this phase 1 diet, the control was a very high crude protein complex, highly digestible nursery diet that performed well. And then we lowered the crude protein by 4 points. So the control diet was basically a 25% crude protein, very high crude protein, highly digestible, and a low crude protein diet that removed quite a bit of fish meal, soybean isolate, concentrate, and then they modified it and rebalanced the amino acids with crystalline amino acids, just to see what would happen if we could gain back some of that performance by using the sensory additive. So it was a 2x2 factorial. But this point was they did notice that there seemed to be something happening, and possibly if we expand replicates and repeat this again, a significant improvement in this sensory additive on a low crude protein diet. But they also noted there was a drop in intake with the high crude protein diet using the sensory additive, and kind of asked what was going on there. So digging in deeper over the first 7 days, they noticed that in the first 3 days, the piglets seemed to have an attraction or a little bit numerically higher intake when the sensory additive was provided, whether that was the aromatic drawing them to the feeder, their curiosity, the familiar smell with the maternal milky type compounds that are present in the sensory additive. But it was kind of lost after 4 days, except in the low crude protein diet. And this tendency seemed to carry out even throughout the first 21 days of the nursery. These two graphs were the phase 2 diet, and then followed with the phase 3 diet, where we reduced the inclusion rate of that sensory additive. But again, the tendency was, why is this sensory additive influencing the control diet? We weren't expecting this. So this is to that hedonic response. The whole purpose of this feed additive in the nursery was to drive in intake and have the recognition that protein is available and it enhances feed intake, that they're getting the energy and the protein they need. What we believe is happening is the sensory additive on top of a high crude protein, highly digestible, complex diet is signaling to the pig, I got enough. It's there, I taste it, I see it. It's not that they have an aversion, that we believe it's actually signaling to the pig, you don't need to eat anymore, because we believe we have plenty of protein energy from this high protein diet. And so that there is more questions to be answered. Could we even go further on a low crude protein diet? Because we are seeing a stimulus and response with increased intake, and it's approaching that of the control diet without the sensory additive. So in summary, in the nursery stuff, the aromatic flavors we know can attract the piglets to the feed. It's getting them to get their first bite shortly after weaning and getting them transition through that stressful period, and having something of familiar smells and tastes that enhance their appetite and their voluntary feed intake. And as we know and has been already previously described, when we get animals to eat and they have the nutrients they need, and we understand how these taste receptors can also signal other functions in the gut, we're having better transition, gut maturation, nutrient absorption and digestion all throughout that early stage of that nursery in a very critical time. And again, the idea is, can we utilize these tools for diet formulation flexibility when there's expensive feed ingredients, and we're looking at how to still maintain performance and intake and still have a healthy pig come out the door at the end of the nursery? What can we do to benefit them using sensory additives? So the applications, shifting gears to lactating sows, they also undergo significant differences in, or significant changes in their ability to consume feed under stressful conditions. So what happens in heat stress is the sow is trying to mitigate her own body heat. They don't sweat and they're just panting. They don't want to eat because eating and digestion increases their heat increment. So their resolve is they're still trying to produce and maximize their milk production for that nursing litter. They mobilize an exorbitant amount of body tissue stores if they have it. If they're coming into the farrowing crate at appropriate body condition score, we know they're going to lose some protein and body fat as they're nursing, but we're trying to minimize those losses. So that's the concept behind the Salvive Luctamax product that we have, stimulating and overriding that depression in feed intake and reactivating and improving their appetite. And in that way, she has that energy need to produce milk to support that litter. And then the litter will benefit having the ability to have the adequate amount of nutrition through the milk. So we conducted a trial in the summer months of 2020 at University of Arkansas. It was a small trial. I believe there was 20 sows per treatment at that time. But what we did see, and this is a tendency we see across multiple trials in Europe, an increase of about 5 to 10% in overall average daily feed intake during that period of heat stress, only fed during lactation. Although we didn't see a statistical difference, there was still a numerical difference. We had less body weight loss for those sows from the time of entry into farrowing, pre-farrow, until they actually were weaned 21 days later. So there was a reduction in their body weight loss reflective of both protein and back fats. They also happened to follow the litters to see where they were going. And there is some effects that we have additional litter data that are showing improvements in reducing the variability of those pigs. We're seeing greater thrivability or livability, if you will. And I have another trial to show that. But basically what we found in the Arkansas study was then the first 5 days post-weaning, the piglets reared from sows fed the sensory additive were 200 grams heavier. Now that difference didn't hold statistically throughout, but towards the end of that 42-day nursery period, we were approaching a trend where those piglets reared on those Luctamax Salvive treated sows were heavier at the end of the nursery period. So the next trials, the larger scale, much bigger numbers. We're talking 380 plus on the first trial and 767 on the second. These were consecutive summers of 2021 and 2022 in Spain. And the daily temperature monitors that they did, they collected every day, averaged at least 25.4 degrees C. That's going to be 78 to 79 degrees Fahrenheit for those in the US. So they were that, and that is the traditional break point of definitely seeing impacts of heat stress on sows. The product was provided in a feed, and they also had a control feed that did not have the Salvive provided. Europe has adopted more crete feeding, so all litters were provided crete feed at the end, or approximately 5 to 7 days of age through the end of lactation. And another note was the second trial actually had a PRRS outbreak. The operators of that farm decided to continue with the trial to see what the outcome was, to see if there was any beneficial effects. So in the first trial, these tables are set up. The sows are on one side and the piglets are on the right side. So on the sows, there was a little bit heavier count of 236 on the control with 147 on the treatment group. Parity distribution was the same. Piglets, farrowed, born alive, and total were near equal. Pre-weaning was pretty close together, but what they did find was that the number of piglets weaned was slightly higher at 0.8 per pig more weaned in the treatment group. And they also noted that there was a slight reduction in back fat loss of the sows. They were actually coming out in better condition with less body fat loss. The piglets, they followed the litters, a subgroup of about 30. There's 29 on the controls and 30 on the treated sow groups. And what they found at weaning performance, they were slightly heavier on the Salvive treatment, and that was as an individual pig basis and total litter weight. They started following the performance of these litters after they were cross-fostered within 24 hours of farrow. What was really interesting was the second trial that was conducted in the summer from June through September of 2022. Shortly after they began the trial, they had a PRRS outbreak that was pretty devastating to them. They made the decision to stay on the trial, and actually we got some pretty good results. They saw an improvement actually in pre-weaning mortality, so they were able to save more piglets, and the sows were eating better. The piglets were heavier, the ones that they did that did survive the PRRS outbreak. They did see about equal body tissue loss in regards to measurements of back fat. That was about the same, even though they started out slightly different, but the differential was the same. So there wasn't much change there in that regard. But what they did see really was in the litter performance. The other interesting performance aspect in the sows specifically was that the treated sows on the sensory additive actually had a better and improved wean to estrus interval of 4.8 days compared to the 5.4 from the control sows. So in response, the commercial operators for this particular farm in Spain were actually pleased with how the Salvive sensory additive worked in their feeds. So overall, we have done several trials in Europe. They were smaller scale, experimental university between Spain and France. We also conducted a small university trial in China in 2022 with results presented at the annual animal science meetings last year. And I'm in the process of working with a university in the States to do a large-scale study for heat stress using this product as well. But the overall benefits in improving is we can see that we are doing something to modify that sow's feeding behavior and increasing her voluntary feed intake. And what that does is her benefit, it's helping her reduce her tissue mobilization and requirement to sustain her milk yield production for her nursing litter. The additional benefits to the litter that we've seen that hold consistent is a little bit better survival on the piglets that are reared on these sows. And a bigger notification is that the piglets weaned seem to be more homogeneous. They're less variation, so you're going to have more full value pigs at weaning. And it seems to be transferring into the nursery and helping with their transition to starter programs where those piglets are a little bit more geared up to transition to those dry feeds and helping them in their growth performance that way. So overall conclusion, palatability and flavors, it is more just than a flavor. There is functional aspect to what we do with these different palatates in stimulating their senses of both the olfactory nerves and the taste receptors and how they work with the brain in modifying those feeding behaviors. We understand that animals can learn and recognize and have pleasurable experiences or environments in order to familiar yourself not only to their new environment, and this is especially important with young pigs or pigs that get transported and moved. If you have something to help in their feed that they can recognize, it helps alleviate some of that stress and encourages early intake. And then the use in the lactation diets, overcoming that heat stress, having sows in better condition, helping promote better productivity overall. And then again, it transfers and benefits to the piglets as well, because if she's not having to over mobilize her body tissue stores, she's coming out better prepared for rebreeding and longevity into the herd. So that is what I had for my presentation today, and I will gladly answer any questions.
Thank you for that very great presentation. We do have some questions from the audience. So the first, how does the age or physiological state of swine affect their response to flavorings in their diet?
So that's a great question. So some of the science, the basic science I didn't get too far deep into is we know that in utero, for example, piglets have and start to develop their initial taste and smell capacity. So they have that imprinting. So there's some work being done, and there are products in the marketplace that are mimicking what they call maternal smells, especially, or maternal taste, whether that they are derived from compounds in placenta or the milk or the pheromones on the underline that attract the piglets. We know that these compounds exist, and there's more products coming to that marketplace. As animals mature, their tastes do change over time. So what a young animal may desire and look for and seek out, such as high intensity sweets to get that energy and umami taste and protein, the umami taste doesn't go away. That also translates to like the mature sow. But the high intensity sweet or that overly sweet, those do change. And those, I guess like in people, we talk about our kids, they may not like broccoli as a child, but all of a sudden they like it as a teenager, as long as it's covered in Velveeta cheese. Your tastes do change over time, and that is the same in different species. So there are certain compounds, but I can speak to pigs. The umami flavor is pretty consistent, whether it's a young animal or a mature sow. Sweetness is on a spectrum. Like definitely the young animals really go after sweet, and that may subside. It's still there, but it just changes as that animal matures.
Yeah, great. Another question, what are the potential challenges or limitations of using functional flavorings in swine feed?
Some of the challenges, so I'll give you on the heat stress. We would love for commercial producers to use this year round. We do see that there's benefits. However, you won't see that improvement of sow feed intake in a thermal neutral environment. You won't get, I mean, in a thermal neutral environment, when those sows are comfortable and they're not under heat stress and they have good, strong appetites, they're going to eat just as much as if it wasn't there. The difference is you'll see some of that benefit in the piglets. But if she's already at a high feed intake and performing well and rears a really great litter, it's harder to tease out those direct benefits that way. But if you have a farm that's a startup with gilts, we can see an impact even in thermal neutral with improving that feed intake on gilts. And very strategic use in thermal neutral environments in that sense. We'd love to get another trial by happenstance. It was just happenstance that they broke with PRRS. Sad for them, but we got some good data. Obviously, there was something happening. They did notice a little bit better feed intake and performance on those sows who were sick, and it translated as well in performance of those litters. So there are strategic times and places to use it, and it's not going to work every time.
Mm-hmm. Another member of our audience has asked if you can comment on the effectiveness of the most successful sensory additives in the presence of diet acidification and or therapeutic levels of zinc oxide in the early nursery diets.
Oh, wow, that's a great question. Then I think this leads back to maybe what Dr. DeRushi was talking about. We want to build and add and have synergistic effects, but sometimes when you do that, you don't always see the additional benefits. In these nursery program diets that we use, I can attest that in the Purdue study, they did utilize pharmacological zinc, and there was no adverse effect. It seemed to do, it was there and present. When it comes to diet acidification, again, depending on which stage, I'm assuming this is going into nursery pigs. We like to talk about having highly acidified diets. It helps with a whole host of things, one with digestion in the stomach for one, and control of microflora and pathogenic bacteria another. There are times and places right now I can get some data to see, but from my experiences in the research recently that I've been involved with, we've not seen any detrimental effects. It just depends what is the objective, what's being used, and how you combine them. I'm a big believer in more is not always better. So you really have to understand what your target is and what question you're trying to answer.
Yeah, no, that's great. Seeing no more questions from the audience, I will thank you again for joining us and for a great presentation.
Okay, thank you.
Thank you. So to close our event, I would like to thank everyone who attended and stayed with us until the end. It has been a pleasure to have you this afternoon. I would like to once again thank our sponsors who made this event possible. Sunhigh, Essential Ag Solutions, MSP Resistant Starch, and Lukta. Thank you and have a fantastic day. I hope to see you all again soon.